Hi, this lesson is for line 4 for Wednesday the 31st of March. Line 6 already did this lesson on Friday last week. So I'll just talk you through this. So this is an introduction to rotational motion. And so the first thing we need to understand is about some of the different types of motion. Now the motion of an object depends on where the force acts. Okay, we learned about the center of mass in the last lesson, last topic. And if you have an object, this red dot represents the center of mass. And if your force acts through the center of mass, then what happens is the whole object moves. Now, this is motion in a straight line, and that's also called translational motion. Now, pure rotation is caused by what's called a force couple. A force couple is a pair of equal but opposite forces acting some perpendicular distance from the pivot. Okay, and that causes rotation. And one of the examples for this is you may have noticed garden sprinklers which turn around. So you have garden sprinklers which are kind of like this. You have a jet of water coming from one end and a jet of water the opposite end, and that makes this whole thing spin around. Okay, so and it waters all the area around it by just having two holes, water equal and opposite forces going in opposite direction. It makes the sprinkler go around. Now, when you have translation and rotation, I kind of draw it. So if you have a single force that's not acting through the center of mass, then what happens is the center of mass itself moves in a straight line at constant speed, and the object rotates around it. So that's both rotation as well as translation. The word translation is to move forwards in a straight line. Okay, now for this topic there are some quantities that's called rotational quantities, and they all have what I call a first name and a surname, or a prefix and a suffix. So one of the quantities that is related to distance or displacement in linear motion is called angular displacement. So now if you look at this disk that is spinning, and we're looking at 2 points A and B on the disk, A is at the rim and B is a point closer to the axis of rotation. So after a time, A has reached that point and B has reached here. Now if you look at them, A has traveled a greater distance compared to B in the same amount of time, so we can say A is going faster than B, linear speed. However, they both go through the same angle theta, and this angle theta is called angular displacement, measured in radians, and it is actually a ratio of distance divided by radius for A is the same as distance divided by radius for B. So the ratio is the same. So that's, and if I rearrange this equation, you get D equals R theta, or theta is D over R. Now, if you're looking at something going a whole circle, the distance around a circle is 2 pi r, and the angular displacement is 2 pi r divided by r, distance divided by radius. The r's cancel. So for a whole circle, which is 360 degrees, how do you convert it? Is 360 degrees is 2 pi radians. Now, objects that are spinning have what we call an angular velocity, and the angular velocity is given by angular displacement divided by time. So omega is angular velocity, theta is angular displacement, and time is in seconds, and the angular velocity is measured in radians per second. Now there's a connection between angular velocity and linear velocity. So angular velocity is theta over t, but we just learned that theta is d over r over here. So if I replace that theta by d over r in this equation, you get d over t, distance over time, is velocity. So you actually have omega is v over r, or v is equal to r omega. Now this is something I'd like you to do, is make this table like this. There are 8 quantities that we'll be learning about in this topic, and each time I teach a new quantity, you're going to fill the blanks in. So today we're just looking at three of them. Time is the same, whether it's linear or rotational. Linear displacement is represented by d measured in meters. The rotational equivalent is angular displacement represented by theta measured in radians. Velocity v measured in meters per second, and the rotational equivalent of linear velocity is angular velocity, and the symbol is omega. It's not w, but it is w where it's inwards like that. It's the last letter of the Greek alphabet, and that's measured in radians per